One good day in geometry. We are moving on to CO2, not carbon dioxide, but using algebra to find segment length and determine if two segments are congruent. Thank you. We mentioned yesterday that algebra and geometry are different in that they use two different sides of the brain, but algebra is still a part of it and that we use it to come to conclusions. And this is our first example of that. What does congruent mean? Actually, similar and congruent are two very distinct definitions. They do not mean the same thing in the geometric sense. Catherine? Yes, congruency basically means the same as. Okay, and when we talk about congruent angles or congruent shapes, we talk about same size, same shape. But there's a difference in geometry between congruency and equality. Okay, saying that two things are congruent, I'm not speaking about their value. Right? I'm saying this is the same as that. It looks the same. It weighs the same size, same shape. The equal sign, though, we use that to show equality, that their values are the same, right? I might have 2 quarters that are congruent, same size, same shape. One's from 2020, one's from 1840. Are they equal? No, the 1840 quarter is going to be worth a lot more, okay, because it's a lot older. So when you talk about congruency, you are really talking about an object. Something is the same as something else. When we talk about equality, then we're talking about value, what something equals, what it's worth, something like that. Okay, this will come up again when we get to proofs, but I'm going to introduce it here because we are introducing segment length. Right? You also today get your very first postulate. We will have postulate and theorem quizzes. A postulate is basically a mathematical statement that's accepted to be true. It has not been proven like a theorem has. When we talk about theorems, theorems are things that have undergone a rigorous testing process, and they have been proven to be true. Postulates are kind of more just things that are accepted. Okay, and so your segment addition postulate, which all the cool people call it the SAP, SAP, okay, says that the parts of a segment will sum to equal the whole segment. Okay, have you ever heard the phrase, a whole is the sum of its parts? Okay, that's kind of where this comes from a little bit. But the parts of a segment will sum to equal the whole segment. And you've been doing this from as early as 2nd grade, and I know that because my 2nd grade kid last year brought home homework that looked a lot like this. I'm like, oh, I'm teaching my 8th graders this. But, you know, knowing if I ask you to find the length of segment GH, if you know that FH is 36 and this part of that segment is 21, what does that leave for GH to be? 15. I should say, not X. Yeah. Good. Claire, Ellen, I don't want to have to ask you two again. Okay, quiet. And where that comes from is that the parts of segment FH, FG, and GH, they will sum to equal the whole thing. So if you know the whole thing's 36, you know that part of it's 21, the other part has to be 15. Okay. The next one, segment WX. You know the whole thing is 144. You know that VW is 37. What does that leave for WX? Joey? 107. Okay. Algebraically, the equation that we're kind of setting up here is, 37 plus what? 37 plus x equals 144, right? And we use opposite operations to solve that. Subtract 37 from both sides, we get 107. Yeah, you have another option? Yeah, what?
Or 144 minus 37.
Sure. You are going back to families. 144 minus 37 equals x. that works also, okay? Or 144 minus x equals 37. There's lots of different ways you can write it, but that's where the algebra kind of plays into this here. Good so far? Do we understand the SAP?
Yeah.
Okay. No? Who said no? Who does not understand the SAP? And so it's fine if you don't, I mean, because you're going to need to know it going forward. So if you need me to explain it again, I certainly can, but are we all good? Okay. This is what your homework is going to look like and what your test questions will look like also. It says point B is between points A and C. So let's just draw this out. Let's put point B between points A and C. We don't really know if point B is closer to point A or point C. We don't know if it's right in the middle. All we know is it's between. So one thing to remember about geometry is that things don't always have to be drawn to scale. If we're just sketching something just to get information down on a page, don't worry about exactly where point B is. It's between A and C. That's all we need to know right now. We're told that AB, that distance, is 2x plus 7. We're told that BC, that distance, is 7x minus 8. Thank you, I can handle myself. And we're told that AC, the whole thing, is 80. So what equation can we set up here that's going to allow us to solve for AB and BC? Ellen?
2x plus 7. Oh, actually, 9x.
Yeah.
Minus 1.
Yes.
Equals 80.
Excellent. Going back to what she originally said, that 2x plus 7, part of the segment plus the other part of the segment will equal the whole segment, right? 2x plus 7 plus 7x minus 8 will equal 80, which is the whole. Part plus part equals whole. She mentally then combined like terms, as she correctly should have, and got 9x minus 1 equals 80. At this point, this is probably a mental calculation for you. What does x equal? 9. Okay. And here's the trap that folks sometimes fall into. X isn't always the answer, right? Solving for x isn't always the purpose here. We solve for x in order to get something else. The question said find A, B, and BC. How's equal 9?
9 divided by 80.
You add 1 to both sides, divide by 9. Right? Okay. So if x is 9 and AB is 2x plus 7, that means that AB is equal to 2 times 9 plus 7. Right? Which is what? 25. It means that BC equals 7 times 9 minus 8, which is what?
55.
Try that again.
54.
What?
55.
55. Thank you, Alexis. Okay. And you can check yourself to make sure that you're right by adding these two together and seeing if you get 80, which you do, which you should. Okay. The next one, point B is between A and C, kind of a similar setup here. Again, we don't know where point B is. That's not really the important piece. The important thing is just get this sketched out. This time, we're given a little bit different information. Lisa, question?
Couldn't you just solve 2x plus 7 by itself? No.
What would you set it equal to?
0, and then you just move it over.
Why would you set it equal to 0? Because 2x plus 7 doesn't equal 0, right? 2x plus 7 represents the length of this part of the segment, which a distance can't be 0 anyway, because then it's not existent. So you have to have something that you know it equals, what its value is. And what we know is that the sum of these two parts is equal to the whole. So we couldn't just set 2x plus 7 equal to anything that we wanted to, right? It's kind of got to fit in context of the question. Okay. This time we're told that AB is 6x plus 12. We're told that BC is 29. And we're told that the whole segment AC is 19x plus 15. What's the equation? Did I make a mistake? Oh, good. I kind of disappointed. So I haven't got to sing my song yet this year, so I'm looking forward to my first. Whoopsie! Yes, Arlene.
So you do 19x plus 15 minus 6x plus 12.
Okay, so we have a couple of different ways we can set this up here, right? Arlene is saying if I take the whole 19x plus 15 and I subtract the part that is 6x plus 12, I'm left with 29, right? And I can solve it that way. The danger with this one, though, is that if you write it the way I just wrote it, you're going to get the wrong answer. The way that I wrote it here, the way that Arlene wants to solve it is fine as long as I make sure what do I need to add to this and where do I need to add them. Beckman? Right. Either I need to change this to a minus 12 or I need to put parentheses around my 6x minus 12 because I'm subtracting the entire value, the entire expression. The way I had it written, I was only subtracting 6x and then adding 12 to it. But the way it's, if I want to subtract the whole thing, I need parentheses. Yeah?
Was it okay that I put 19x plus 15 on top of 6x plus 12 and then subtract it?
Combining polynomials. Way to reach back from last year. Yes. As long as... What Arlene's asking, if I'm understanding correctly, is she set it up vertically to combine the like terms there. And then if you go back to this sign, so you take 15 minus 12 to get 3 here, yes, that would be okay. That would be okay. Okay, so that's one way to set up. Ellen. You could also do 6x plus 12 plus 29, the two parts added together to equal the whole. And this is why variables on both sides was a part of your entrance exam. So you reviewed how to do it so that we don't have to relearn that process here, right? You could set it up that way also. This is why geometry is a different side of the brain. In algebra, it's like, this is what you do. This is the equation. This is the process. This is the answer. Here, we've already looked at 3 different ways you could do it, right? You still have to eventually get to the algebra, but it's more right brain because there are more options. You can get creative with how you want to solve it, okay? Lisa.
How would you put the equation from like in the corner into like into it?
So then you would take this and you get 13x. Okay, and then you would set this equal to 29 and solve it. Because what you did to get here was you took the whole, subtracted the part, and if you take the whole thing and subtract the part, you're left with the other part, which is 29. Okay, so that was kind of an intermediate step, what she did there to get that piece, and you set it equal to 29. What's that? You have a question? Okay, can you sit flat, please? Thank you. Vince? Quiet. So, because what Arlene did was she took the whole thing, 19x plus 15, and subtracted this part of it. And if you start with a whole and subtract a part, you're left with the other part, aren't you? Yeah. So that's why it equals 29, because that's the part that's left. Right? It does mean that x equals 2. Yes. Okay. So then plug that back in for AB and AC like we did before. 6 times 2 plus 12 is 24. And 29. That means that 19x plus 15 should equal 53 because 24 plus 29 equals 53. If you plug 2 into 19x plus 15, you do get 53. So it all checks out. That's the other nice part about geometry, is that it's like a big puzzle. When you're done, everything should fit. It's a lot easier to check your answer in geometry than it was in algebra. Okay? Yeah.
And why did we minus the 19 minus 6? On the top, right?
Up here?
Yeah.
Again, going back to the way that Arlene wanted to set this up, she was subtracting the part from the whole, so she knew what she'd be left with. So 19x minus 6x is 13x. 15 minus 12 is 3. So this 29 that was left over is equal to that expression. That allows us to solve for x. Most of you probably set it up like this, which is fine too. Okay, that's just another way. Your homework for tomorrow. On page.
Do we have to do the bottom?
No. On page 12. On page 12. I would like you to do 6 through 11. And 21 through 26, comma.
No, you're serious? I know.
That's bullying. The 6 through 11 one.
6 through 11, 21 and 26, 28 and 30. This symbol here means show work. And so you need to be showing your work.
What does it do?
I will give you 23 hours and 15 minutes to get this done. Tomorrow at noon o'clock. Questions, comments, concerns, complaints, compliments, congratulations? Yes, Kylie. What's your complaint? It's not that much. I'm giving you a high school credit for this course. With that attitude and criticism. Aiden. Thank you, Aiden. CRISPR. Where's he go? Where's he go? Oh. Yeah. Look forward to high school then. I don't know. All right, folks, with gusto, that's how you math.